The heating element of a toaster has a resistance of 100 ohms. If it's connected across 200 volt supply, find the heat produced in 10 seconds. So let's try and write down what's asked of us. We are asked to calculate the heat produced in that heating element in 10 seconds. So let's write that down. H for heat. We need to calculate heat produced in 10 seconds. This is what we want to calculate. And what's given to us, that's always the next step for me. What's given to us are, let's see, the heating element of a toaster has a resistance of 100 ohms. So we are given the resistance of the element. So the resistance of the material is given to us 100 ohms. And we're also given it is connected across 200 volt supply, so which means voltage is given to us. So V is 200 volts. So what's going on over here? Well, just to give some context, in a previous video we've seen that when you have a current passing through any material, due to the resistance of that material, there will be heat generated. And we also derived a formula to calculate that heat generated in that material. And we found out that the heat generated in any material due to its resistance, due to the electric current, that can be calculated as, let's write that down here, heat generated per second. That can be calculated as the product of voltage and current. And if you are not clear about where this comes from, we need more clarity on this. We have derived this in previous videos, so it'll be a great idea to go back, watch that video, and then come back over here. But this is the basic formula to calculate the heat generated in any resistor per second due to the current. But wait a second, you may be wondering, well, there is no current given in our data. So how do we calculate it? Well, remember Ohm's law? Ohm's law connects voltage, resistance, and current. And Ohm's law was V, let me write that down over here, V equals I times R. So if you look at this carefully, one way we could solve this is we can calculate what the current is in this heating element by using Ohm's law, and then we can substitute that over here. Or we can directly substitute this in our formula. So let's do that. So if we substitute Ohm's law in our formula, there are two things we can do. One, we can substitute V as IR. So if you substitute IR over here, we'll get I squared times R. So that's another formula for us. And one more thing which we can do is we can get rid of I as V over R. So if we substitute V over R here, we'll get V squared over R. V squared over R. And now, because we are given voltage and resistance, all we can do is directly go ahead and use this formula to calculate the heat produced every second. And then from that, we can go ahead and calculate how much heat is produced in 10 seconds. So it would be a great idea to pause the video right now and see if you can try this yourself. All right, let's do this. So heat produced per second. I'll go with this one because we know the voltage and the resistance. So voltage is 200, so that's 200 squared, right? That's 200 times 200, divided by R. I know we can cancel some zeros, that's why I write it as 200 times 200 instead of 200 squared. And so I can cancel two zeros over here, and that gives me 400. 400 what? Well, look at it, you have heat. Heat is energy, so it's joules per second. So 400 joules per second. So what we have calculated is that in this heating element, there'll be 400 joules of heat produced every second. But we are asked to calculate the heat produced in 10 seconds. How do we do that? Well, we know in 1 second, there's 400 joules of heat. In 2 seconds, it'll be 2 times that. In 10 seconds, it'll be 10 times that. So last step, heat in 10 seconds. That's going to be 400 joules per second times 10 seconds, and that's going to be 4,000 joules. So the total heat produced in 10 seconds in our heating element is going to be 4,000 joules. All right, let's solve another one. A bulb produces 240 joules of heat every minute when the voltage across it is 2 volts. Find the resistance of the bulb and the current through it. So the concept is very similar. It's about heat generated per second, but this time we are given the heat generated every minute, and we have to find the resistance and the current through the bulb. So let's again go ahead and write down what's asked and what's given to us. What's asked is we need to calculate the resistance, R, and we need to calculate the current. Let's use the same color, yellow, I. And what we are given is heat produced every minute. So let's write that down. Heat per minute, that's given as 240 joules per minute. And we're also given the voltage across it is 2 volts. Voltage is 2 volts. The concept is similar, so let me write down the same thing that we wrote earlier. We know heat produced every second is V times I. That's our basic formula to calculate electric power. Here the power is dissipated as heat, energy per second. And then we can also use Ohm's law, and we can write this as I squared R, which is also the same as V squared over R. V squared over R. And if you look at it carefully, we are given heat produced per minute. From this, we have to calculate what is the heat produced per second. That's going to be our first step, because the formula over here deals with heat produced per second. But once we know that, then we know this, and we know the voltage. So from that, can we calculate the current? Yes, we can. We can use the same formula as before and calculate the resistance, and then maybe we can go ahead and calculate the current. So again, pause the video and see if you can try this yourself. All right, let's do that. The first step, as mentioned, would be to calculate heat produced per second instead of per minute. So how do we do that? Well, what we can do is we can convert minutes to second, because I want second in the denominator, right? So this can be written as, so let's write that down somewhere over here. Let's continue this. 1 minute is how many seconds? 1 minute is 60 seconds. So I would just write this down, joules per 60 seconds. And the zeros and the zero cancel, and so I end up with 24 by 6, that's 4 joules per second. So that's how much heat is produced in our bulb. And now that we know this, we can plug it in over here. So I'm going to use this formula. Heat produced per second is going to be V squared over R. So let's make some more space over here. All right. So heat produced per second, that's 4 joules per second. I'm not gonna put in the units because I already know the unit of resistance. That's ohms, right? So I'm not gonna put in units over here. So 4, that's going to be V squared over R. V is 2, so V squared is 2 times 2 divided by R. And then we can just do the algebra. We can multiply both sides R, and we'll divide by 4 on both sides. So we'll get R on the left hand side, and that'll give me 2 into 2, that's 4 divided by this 4. This cancels and it gives me 1. So I get 1 ohm. And that is the resistance. So the resistance of the bulb must be 1 ohm. All right. What else do we want to find out? We want to find out what's the current. Well, now there are a couple of ways in which we can do this. Either we can go ahead and use Ohm's law, V equals IR, because we know V and we know R. Yeah, we know R, and so we can go ahead and calculate I, or you can also use this and calculate. You should get the same answer. So I'm just gonna go ahead and use Ohm's law. I'm gonna go ahead, V equals IR, so I would be V over R. Let's write that down over here. I equals V over R, V over R, and that's going to be V, which is 2, divided by R, which is 1, and that's going to be 2 amperes. 2 amperes. And so that's the current through our bulb. And this is the resistance through our bulb. There we have it.